So let's look at an example which is a little bit more complicated. So example 2, we have a weighted mass is attached to the end of a spring that when released from the origin point, moves up and down in a straight line. So suppose that 10 centimeters is the maximum distance the weighted mass can reach from its equilibrium at d equals 0, and the time it takes for this mass to move from its maximum displacement upward to its its maximum displacement upward to its maximum displacement downward is t is equal 4 seconds. Assume no friction or air resistance. We want to create a mathematical model for this. So the fact that we are saying that there's no air resistance and there's no friction, this tells us we're going to be using harmonic motion. So let's pick out some other important things. So we know that 10 centimeters is going to be the maximum displacement. So that's going to give us our amplitude. We're going to be starting from the origin point, which tells me I'm going to be using sine instead of cosine. And I know that I have a period of t equals 4. Because remember, this is for that to make a single cycle. So where the mass is moving from its maximum displacement upward to its maximum displacement downward, which is one single cycle. So since d is equal to 0 when time is equal to 0, this only makes sense to use a function of sine, again, because we're releasing it from our origin point. We know that our amplitude is going to be 10 since this is the amplitude of the motion, or alpha is going to be 10 because this is amplitude. Lastly, we know that 2 pi over omega is equal to 4, which means we can solve 2 pi of omega is equal to 4, so 2 pi is equal to 4 omega, which in this case gives us 2 pi over 4 is equal to omega, or that our omega value is going to be pi over 2. So we took a bunch of information that we knew to find a bunch of information that we didn't to find our mathematical model, which in this case is going to be d of t is equal to 10, because again that's our maximum displacement, sine, because this is released from the origin point, times pi over 2 t, because pi over 2 was the omega that we found based on what we know about the period. So again, this one isn't too much more difficult. It just takes a lot of thinking about the information that you're given and plugging them into those empty holes. We know we have to find an alpha and we have to find an omega, and essentially taking this from a large word problem, or what just looks like a big mass of words, is sometimes not that easy.